Hey guys, today we're going to have our last lesson in chapter 4 on accident investigation data. How can we use math to understand evidence of an accident? Okay, so we did last time, we did some stopping data. Okay, and so we can use math to use stopping data to look at skid marks. We can tell how they can often tell how fast somebody was going. They can tell whether somebody braked or not. I mean, if there's no skid marks on the road and you hit somebody, they know you didn't put the brakes on. Or if you go off the road, they know that. There's a lot that can be told. Especially, you can look at how much damage is done to a vehicle. If somebody's thrown from a vehicle, you can tell how fast they're going from how far the person was thrown from a vehicle. So what does a police officer use to reconstruct an accident? Like I said, skid marks are one big thing. Damage to vehicle. Distance people thrown from vehicles. Okay. All righty. So we've got a shadow skid mark. So when you first put on the brakes, a skid mark is very light, and that's called a shadow skid mark. Okay, so it's light marks made when you first put on the brakes. They get darker as you slow down. ABS. Okay, ABS stands for anti-lock brakes systems. Okay, if you've never driven with anti-lock brakes, it's a bit different. Okay, here's the difference. If you don't have anti-lock brakes, what happens is you put the brakes on really hard and it will lock up those tires. They will stop and you will start to slide. You will have no control over the vehicle. Okay. With anti-lock brakes, what they do is they apply the brakes, they let them off, apply the brakes, let them off, apply the brakes, and let them off. And it does it automatically, so you don't have to do it. It does it much quicker than you could possibly do it. And what it does is it prevents you from locking up the wheels. And it feels like you're not going to stop in time, but you actually stop much quicker. Yaw marks. Okay, so a yaw mark is when the tire marks curve. Okay, so the vehicle starts to slip to the side as it continues forward motion. So it's the curvature of the tire marks in the skid. Okay, so if you look at the marks, they tend to go like this. And it's not necessarily from you putting on the brakes, or from steering, sorry. It's not necessarily from you steering. Okay. The skid speed formula. All right, so the square root of 30 times d times f times n is the square root of, is It's also written like this. You don't need the parentheses. Where S is the speed of the car, D is the skid distance, and F is the drag factor, N is the braking efficiency. So the skid distance, D, is a function of the number and lengths of the skid marks left at the seam. Somebody got paid a lot of money to figure this out. This is a class called math modeling in college that you would take. Doesn't sound like it's very difficult, but it is a pretty difficult class. I would say it was probably the second hardest class I took in college. So the skid distance, D, is a function of the number and lengths of skid marks left at the seam. F is the drag factor, and that is the pull of the road and the tires. This will vary from surface to surface. It's the amount of friction on the road. So here's a couple of drag factors. If you're on cement, the drag factor can be anywhere from 0.55 to 1.2. On asphalt, from 0.5 to 0.9. On gravel, from 0.4 to 0.8. On snow, from 0.1 to 0.55. And on ice, 0.1 to 0.25. What you want, if you have to put on the brakes, is you want the drag to be bigger. Okay, it lets you stop sooner. So the braking efficiency is determined by examining the brakes. It can vary from 0, which is no brakes at all, to 100%, where the brakes are in perfect condition. It's expressed as a decimal. Okay, and it's in a percent. So 0.85 would be 85% efficiency on your brakes. So a car is traveling on an asphalt road with a drag factor of 0.78. The speed limit on this portion of the road is 35 miles an hour. The driver just had his car in the shop, and his mechanic informed him that the brakes were operating at 100% efficiency. The driver must make an emergency stop where he sees an obstruction in the road ahead of him. His car leaves 4 distinct skid marks, each 80 feet in length. What is the minimum speed the car was traveling when it entered the skid? Round the answer to the nearest tenth. What was the driver exceeding the speed limit as he was driving? Okay, so our formula, remember, is S equals the square root of 30 dFn. Okay, so let's see, what do we have here? We've got the skid mark, 30. So the distance of the skid marks is 80 feet. Let's put this here in blue. So this is 80. Okay, and F is the drag factor. Okay, so F right here is going to be 0.78. N is the condition of his brakes. We're at 100% efficiency. So that's just going to be 1.00. Okay, is going to be his efficiency there. So now we just figure out what S is. Okay, so we get out our calculator, and we've got, or this is the speed, so the square root of 30 times 80 times 0.78 times 1 comes out to be 43.27 miles per hour. Okay, so was he exceeding the speed limit? Well, yeah, he was, because the speed limit, 35 miles an hour. Is he going to get a ticket? Yep, he's going to get a ticket because he caused an accident. He was exceeding the speed limit. Okay, so there you go. Example 2. Car is traveling on a gravel road with a drag factor of 0.65. Posted speed limit is 15 miles an hour. The driver recently had her car in the shop, was told her brakes were at 80% efficiency. The driver makes an emergency stop where she sees an obstacle ahead. The car leaves 4 skid marks with an average length of 20 feet. What speed was the car traveling when it entered the skid? How does the speed compare to the posted speed limit? Okay. So let's write down your formula. S speed equals the square root of d times, what do we use here? D, it's 30d. So 30 trying to color coordinate this stuff for you. 30, D was blue, F was green, and N was purple. Okay, so here's what I'm going to let you do. I'm going to let you do this problem. I want you to pause the video here and then jump back on here and see if you got the same thing I did. Okay, so her speed is the square root of 30. Okay, so D was the length of the skid marks. That was 20 feet. Okay, F was the drag factor, 0.65. And N was 80% efficiency, so that's 0.80. Okay, so there's your problem. It's just a calculator question now. So we're going to take the square root of 30 times 20 times 0.65 times 0.8. Now, depending on what kind of calculator you have, you need to make sure that all of this is under the square root, or that you calculate this number under here before you take the square root. Okay, so her speed came out to be a minimum of 17.66 miles per hour. All right, it was a 15-mile-an-hour speed limit. Would she get a ticket for going 3 miles an hour with a speed limit? I don't know. Probably not. Depends on what happens in the accident, maybe. Melissa was traveling 50 miles per hour on a concrete road with a drag factor of 1.2. Her brakes were at 90% efficiency. What would you expect the length of the skid marks to be if she applied her brakes in order to come to a full stop? Okay, so this is the same equation, just slightly different problem because I have different information. Okay, so if I go back here again, S equals the square root of 30 times D times F times N. Okay, so this time I've got S, it's 50 miles an hour. So I know how fast she was going. Okay, D, the drag factor. Or no, sorry, D is the distance. So that is what we are trying to calculate. What would you expect the length of the skid marks to be? So that's going to be D. F is the drag factor is 1.2. And N is the 90% efficiency, that's 0.9. Okay, how do I solve this problem? Well, probably what I would do is I would get all this stuff kind of simplified underneath the square root sign here first. So 30 times 1.2 times 0.9. So this is 32.4 times D. Okay. Now I got to get rid of the square root, so I'm going to square both sides. So 50 squared is 2,500. That equals 32.4D. Square root's gone on this side now. So now I can simply divide both sides by 32.4. And I get D is 77.16. And that's going to be in feet. Okay, so that's how long they would think those skid marks would be if she applied her brakes. Neville was traveling at 30 miles an hour on an icy road with a drag factor of 0.15. His brakes were at 95% efficiency. What would you expect the lengths of the skid marks to be if he applied his brakes in order to come to a full stop? So again, here's my formula. S equals the square root of 30 times D times F times N. Okay, I'm going to let you pause the video here, and then you can calculate this and then come back and compare it to what I get. Okay, so again, we know the speed was 30 miles an hour. So that goes here. 30 is right there. The distance D is what we're calculating. F is 0.15 because it was icy, so it's not going to give him much drag. But his brakes were in pretty good shape. They were 95% efficiency, so that's good for him. Okay, so then I'm going to calculate the stuff, the numbers under the square root. So that's going to be 30 times 0.15 times 0.95. That's going to be the square root of 4.275 times D over here, and that's going to equal 30. All right, now I want to square both sides of this to get rid of that square root. So this is going to be 900. 30 squared is 900. And then I'm going to divide by 4.275. It'll take this guy a long time to stop here. So D comes out to be 900 divided by 4.275. 210.5 feet. That's how long the skid marks are going to be. If he has skid marks, that's how long the skid's going to be. Might not leave marks on ice. Okay, the Yaw Mark formula. So S is the square root of 15 times F times R, where S is the speed of the car. 15 is the constant, so it's always 15. F is the drag factor, R is the radius of the yaw marks, which is calculated by the following formula. R equals C squared divided by 8M plus M over 2. Okay, so M is the radius and C is the length of a chord, and Y is R is the radius of the yaw mark. Oh, M is the length of the middle ordinate. Okay. So, I'm sorry, M is, okay, this is Y right here, is this right here. And this is the middle ordinate right here. So what they do, here's the curvature, okay? They calculate this chord right here. They find the center of the circle right there. They calculate this where it intersects that chord. Okay, and all that's factored into this. Okay. So an accident reconstructionist took the following measures of yaw marks left at the scene. The chord was 62.4 feet. So let's get the equations over here. So S equals square root of 15 FR. Okay, and then our other equation is R equals C squared over 8M. Plus M over 2. Okay. The chord was 62.4 feet. So that's C. Okay, so we're going to plug that in here, 62.4, and we're going to square that. The middle ordinate was 5 feet, so this is going to be 5, and this is going to be 5. And now we can calculate R. Okay, so I get out my calculator, and I do 62.4 squared divided by 40. 8 times 5 is 40. So this is 97.344 plus 2.5. 5 divided by 2 is 2.5. So R is 99.844. Okay. Now, S is going to be the square root of 15. The drag factor was 1.2. And R is 99.844. Okay, all this stuff looks scary, but it's really not that bad. All right, so 15 times 1.2 times 99.844. All right, this comes out to be the square root of 1797.192. I'll square root my answer there. S is 42.39. Okay, that's the speed of the car in miles per hour. All right, you're going to do your last 2 pages of your packet. So there's one. Rhonda was driving on an asphalt road. Here's page 2. Sadie's car gets 28 miles to the gallon. Whoops. And that's it. And we're done with this chapter. So we'll have a review next time, and then we will take a test. So have a great day.